today we'll be presenting our senior design project, which is supervised by Dr. Arif and Ms. Martin. So our project is a self-learning architecture, which changed since the midterm, which was self-learning colony, responding to the feedback that we got in the midterm. And also, since we're doing architecture engineering, we want to have the self-learning part, which talks about the technology and engineering, and the architecture, which is about the elegance. So starting with the background, artificial intelligence is no longer just the theme of science fiction movies. It is a reality that's shaping our present and future. And with the appearance of the humanoid robots like Sophia, she revolutionized what we perceive was possible with technology. The use of AI in architecture is already being expressed through things like parameterism, where AI softwares are used to, in the process of form finding, to generate different forms which are difficult to be visualized or drawn by hand. Here you can see a sci-fi futuristic movie called Tomorrow's Land, where they use the design of the architect Santiago Calchava to predict how future cities would be like. A lot of the great innovations in AI and technology was inspired from nature. Robots are being designed to mimic how we naturally interact, communicate, and learn from each other. This also expanded to architecture through biodigital architecture by mimicking nature to solve design problems. The next thing that we'll be talking about is the problem statement. So our theme in this project is to integrate artificial intelligence technologies to create a smart building that can adapt to future challenges. And this is where the term self-learning comes from, which is like an architecture that can adapt from all aspects, the environmental, the social, the economical, and any other aspects. Here are some of the challenges that our building would adapt to. First of all, it could be a pandemic crisis, which can be dealt with through using the nanotechnology and smart materials, which are inspired by the Sharjah, for example. These materials do not become germs and they can be placed on the building interiors. Environmental conditions similar to this robotic glider, which generates energy solely from the sun and water waves. Structure through using high-tech robots like the KUKA, which can help in building complex structures. Maintenance for performing tasks like cleaning the building exterior more efficiently with robotic machines. Fire control for detecting and diffusing fire safely by using explosion-proof robots like these ones. Energy monitoring to keep track of the energy consumption and generation of the building. Flexibility and adaptability, which is using machine learning to predict and adapt to any living needs that might emerge in the future. The next thing that we'll be talking about is the goals and objectives. So our first goal here is to create a new AI-based lifestyle building where machines are part of our lives and can help us perform the mundane task that requires a lot of point repetition, and then help us focus on the task that requires more creativity and innovation that cannot be performed by robots. Use AI technology to adapt to future challenges, similar to the penguins who can adapt by growing waterproof skin to help them survive harsh conditions. We could also create a building skin, for example, that can react and adapt to future challenges. Using technology to achieve sustainability, similar to this adaptable homeostatic building skin, which was inspired from the human muscles, where it opens and closes using electric shocks, similar to how the human muscles expand and contract. Open the door for future AI building in the region. Since our building will be the first AI building in Dubai, we're aiming to set the standard for making more AI buildings in the region. The next thing that we'll be talking about is the significance of the study. So for our first significance is to be part of the digital era. Now, the digital transformation is already taking its steps in Dubai, which can be seen here in the most recent Dubai police technology, like the robotic helmet. Also, it can be seen in the robotic cafes like this one, which is the Robo Cafe in Dubai Festival City. Create a better quality lifestyle through using self-driving cars and drones, for example, which are becoming more popular and are shaping the future of transportation. Adaptability to challenges. Technology can be used as leverage to create a more sustainable building structure similar to this one, which can respond to the environment. Innovation of better methods to respond to environmental conditions, like in creating an environmental responsive form where the building form help in reducing the energy consumption. The next thing that we'll be talking about is the methodology. So our methodology starts by defining the theme of our project, and based on that, we make a theme-based research made of the case studies and literature review, which help us select a proper site for this project. Then we perform a site analysis with simulation and modeling. We use all this information to have design guidelines, which help us create our project program. Then we experiment with this project program by making an experimental study, which we get a research outcome. Then we simulate these research outcomes again to test our result, which we end up with a design proposal. And then for the final time, we simulate our design proposal and we end up with a final accurate design proposal. The next thing that we'll be talking about is the literature review. So our literature review is divided into 4 parts. The first part is how AI changed our lives. Now, AI and technologies help us in expanding our abilities rather than replacing us, and we're not so far from the technologies of making superhuman intelligence, which we can see here in the most recent technology where chips are inserted into the human brain to restore a lost ability like walking or seeing or to predict human behavior. The next thing, which is a rather important part, which is the role of AI in design, because AI excels in the design sectors, like in architecture design, structure, construction. An example here, you can see using the VR and AR technologies in the construction process, which can help you, for example, generate a real-time model on site of your building. AI and adaptive structure. An example of that is making adaptive building structures which are controlled by smart sensors that can help in adapting to challenges, which is very important for making an environmentally responsive building. Self-learning materials, which are materials that can change their properties based when they get exposed to external stimuli, such as biomaterials or the nanotechnology. These materials have great application making building skins such as self-cleaning glass. The next thing that we're going to talk about is the case studies by my colleague Islam.
Okay, so we have 3 case studies, one regional and 2 international. The first one is Kapsar. It's done by the Hadid Architects in Saudi Arabia. And in this project, they use intelligent software like Grasshopper to generate the form of this building, which was inspired from this grid of Voronoi and bubbles. And here they reach this environmentally responsive form by a lot of factors, like hexagonal grid that let you build with less materials and adaptability to the form for any future expansion. The open patios here are oriented to the north to bring indirect sunlight into the spaces below. The wind catchers are integrated in roof profiles to catch the prevailing winds from the north, cooling each courtyard. The canopies here integrated between the buildings to shade the corridors so that the people can walk under the sunlight. Next, with Galaxy Soho, also done by the Hadid Architects in China. And here they use AI software and the contour strategy to be able to control the complexity of this shape and help them to create a shape that would be hard to design manually. We are interested here in this curvaceous structure and the fluidity of this building, and most importantly that we want to implement in our project the connectivity between the buildings by the bridges in different levels. Also, the open space courtyards here are creating an internal world of continuous open spaces. And last, the central atriums are very important for the natural ventilation and sunlight to reach all the facilities in the building. Next, the shed. And it's done by Der Scofido, Renfro, and Rockwell Group in New York City. Here, the new idea here that the movable steel shell covered by ETFE panel transformed physically on a double wheel track. We are interested here in the flexibility and multi-purposes in the functions. So they have the MC cord and is formed when the movable shell, outer shell is deployed over the adjoining plaza to create a light, sound, and temperature controlled hall for large scale performances, installations, and events. And the Tish skylights and lab are striking spaces for events rehearsals, and artist development. The kinetic-driven theater, and this it can function as a theater or subdivided into more intimate spaces to suit the needs of a range of productions and installations. Here the galleries are taking two floors. They are expansive, column-free, museum-quality spaces. And the last and most important space is the plaza, and this can be used as an outdoor public space for any event when the movement shell is retraced to nest over the base building. Next, the site with Osama.
Yes. Uh, with the vision of His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the United Arab Emirates and ruler of Dubai, to make Dubai the happiest city on earth using technology innovations. This makes Dubai a perfect candidate to accommodate our self-learning building. Our site is located next to Dubai Design District, viewing Dubai Canal from the north side and Sheikh Zayed Road skyline from the west side. We chose the site because it reflects the project form through the outlines, and it also complements the theme of our project with Dubai Flamingo Sanctuary located towards the east side of the site. For the shadow analysis, we used an AI software like Rhino to simulate the behavior of the shadow in our site on a simple mass. The simulation was done for 4 different months as shown in the figure. March represents the beginning of the spring season, June, which has the highest temperatures of the year, September, that represents the beginning of the fall season, and December, that has the lowest temperatures of the year. From analyzing the simulation outcomes, we can see that the longest shadow casted by the object is 3.4 meters long in December, and the least amount of shadow casted was in June. The data analyzed helped us understand the behavior of the shadow in our site to identify the ratio between the height of the object and the shadow cast length. From analyzing the site, we know that the topography is flat. In the top right corner, you can see a QR code that will take you, once you scan it, to pictures and videos of the site from our site visit. The noise analysis diagram shows that the west side of the site is noisier than the east side due to different activities happening in Dubai Design District. In addition of two open event areas, two music venues, and a power station located in the south side of the project. The site is also accessible from three main roads connected to secondary ones that shapes the outlines of the site. Also, different transportation systems are available around the site with 4 parking lots, 3 bus stations, and a single water taxi station, walking track, and a cycling track. According to the methodology mentioned earlier, the analysis of the case studies along with the site will help us develop design guidelines to follow through the project. Our self-learning project is relatively a new typology of buildings to the United Arab Emirates. It will highlight the improvement of AI integration with the educational and commercial facilities. The design guidelines that we are considering for the project can be categorized into 4 categories. Site guidelines that will help us knowing the building's setbacks and heights, along with the landscape design for the surroundings. Our sustainability guidelines that were inspired by the environmental responsive forms explained earlier in the case studies to develop active and passive design strategies. Architectural guidelines to generate site reflective forms and how AI tools will affect functions within the project, like generating new educational guidelines which are affected by the online learning technologies. From an urban perspective, we included some smart features like the usage of autonomous cars, which is going to generate new guidelines for the transportation system and the parking lots. Finally, the structural and construction guidelines highlighting the usage of smart building materials and constructional methods like the 3D printing. Moving on next to the project program. The site has a total area of 77 and 300 square meters, divided into building footprint, landscape and open space, and AI infrastructure, with the percentages of 50, 30, and 20%. The building footprint has two building typologies. First, we have the commercial buildings with a percentage of 60% of the footprint. The second building typology is educational with a percentage of 40% of the footprint. Each type has different facilities related to our AI projects team. Commercial facilities will include an AI mall, headquarter, two retail business buildings, a hotel to accommodate expected visitors to the site, and an all-year-long AI dynamic theater inspired by the shed, the case study presented earlier. Moving on to the educational facilities that will include a research center, digital library, virtual reality rooms, an AI art gallery exploring different ways of how artificial intelligence can create art, a hologram exhibition hall, intelligence labs, computer animation studios, and offices for the faculty. These areas were affected by our accepted competition submission announced by His Highness Sheikh Mohammed bin Rashid to visualize the future of education in the United Arab Emirates for the next 50 years, using different AI technologies like the mixed virtual reality classrooms, quantum computing, and the humanoid AI teacher, which will result in using less need for conventional classes and will also focus on the benefit of personalized tuition experience thanks to the humanoid AI teacher that can understand students' emotional states from their facial expression, body posture, and tone of voice, highlighting the role of the academic instructors managing such technologies. Moving on next to the concept development.
Since our project is a self-learning colony, so it only makes sense that we integrate artificial intelligence technologies in making the concept of the project. Uh, so, um, so we use these technologies like the coding language which we had to learn to sketch out the inputs or that we gathered from the case studies, literature review, and that we got from the site analysis and program. These technologies help us in to identify the bubble diagram and understand the relationship between the functions, circulations, and the behavior of how it changes when you change one of the parameters. Here you can see a grid of the bubble diagram, which is made based on the parameters of our project. Let's have a more in-depth look of it. First of all, we have started by putting these outer lines, which represent the connection between our site and the surrounding buildings. It is an idea that we inspired from the Galaxy saw from our case studies. Then we identified different potential points for accessibility to the site and road connections, which are shown here. The next set of points are the ones resembling the main functions of the building, the education and the commercial one. And below it, there's the commercial, there's also the potential bubble diagram, which shows the different functions that we studied in the project program. These lines help us study the potential connections, point of view, accessibility, ramps, entrances, meeting points, and pedestrian paths. As you can see here, when I move one of the points, the entire system responds and adapt to the changes. If you look on the right, you would see that the areas are changing whenever I change one of the parameters. This system doesn't only stick to 3D, it also plays with 3D with different levels for each point, similar to how they did in the case studies. This technology is a proof of the potential of AI in the design for producing designs that are very difficult to be visual or sketched by hand, which enables a new era for architecture and design. On that note, we end our senior presentation. Thank you.